Hello, my name is Emiliano Carranza Barragan, and I will be explaining the mechanical properties of the rubber bands in an experiment. The materials that we used were rubber bands of different length and also small weights of 150 grams. The experiment consisted of we attach a base to the rubber band, and each time we placed the weight, and with a ruler we measure the deformation, and we repeated this process until the rubber band broke. For the experiments we use the following formulas. For the strain we have the final length minus the original length divided by the original length, and for the stress it was force divided by the area. In this case, the force is the mass times the gravity times the number of weights that we added, divided by the cross-sectional area of the rubber band. The initial length for this rubber band, that was the smallest rubber band, was 0.02 meters. We used Excel to create a table with the deformations. For the strain, we use the formula for each deformation that we measured, and the stress we multiply the mass of the disk times the gravity times the number of disks that we use divided by the area, and we obtain these values. They're in pascals, and with them we created a stress strain curve for the rubber band, for rubber band A. We also repeated this process but for the second rubber band, and again we measure the strain compared with the original length, that in this case was 0.07 meters, and the stress we did the calculations, and we also obtained a stress strain curve. Conclusions of this experiment: the stress strain curve for an elastomer behaves differently than other materials such as metals and ceramics. The proportionality between strain and stress is not linear, so the Young modulus is different in every increment of strain. We also saw that rubbers can undergo large deformations.